in section 11.1. In this section, we're comparing two population proportions to each other. So in this chapter, instead of just looking at one parameter, we're looking at two and making comparisons. So let's try this example. The drug Prevnar is a vaccine meant to prevent certain types of bacterial meningitis. It is typically administered to infants starting around 2 months of age. In a randomized, double-blind clinical trials of Prevnar, infants were randomly divided into two groups. Subjects in Group 1 received Prevnar, while subjects in Group 2 received a control vaccine. After the second dose, 137 of 452 subjects in the experimental group experienced drowsiness as a side effect. After the second dose, 31 of 99 subjects in the control group, Group 2, experienced drowsiness as a side effect. Does the evidence suggest that a lower proportion of subjects in Group 1 experienced drowsiness as a side effect than subjects in Group 2 at the alpha equals 0.05 level of significance? Okay, part A is just asking us to check the requirements. In order to do that, we need to first make sure that this either came from simple random sampling or a randomized experiment. So here we see that it was a randomized experiment, so we're okay for that requirement. The next requirement is that the sample size times the sample proportion times 1 minus the sample proportion is greater than or equal to 10. So let me write that down. So this has to be true for both of the samples. In this chapter, we will always have two samples. So in order to check this requirement, we will have to compute the sample proportions for both of them. So let's go ahead and make some notes up here. So p hat 1 will be x1 over n1. And we got that group 1 right here. So 137 out of 452 of the infants experienced drowsiness. So let's get a value for that. 137 divided by 452. So p hat 1 is about 0.303. We also need to compute p hat 2, the second sample proportion. So that will be x2 over n2, and I'm seeing those values right over here. 31 of 99 subjects in Group 2 experienced drowsiness as a side effect. So 31 divided by 99, let's get a value for that as well. Okay, about 0.313. Okay, so now we can use those to check that n times p hat times 1 minus p hat is greater than or equal to 10. So n1 is 452 times p hat 1 times 1 minus p hat 1. So let's figure out what that is. So 452 times 0.303 times 1 minus 0.303. It's 95, about 95. It doesn't really matter what it is. As long as it's greater than 10, we're good. Okay, so let's try that for the second sample. The second sample size was quite a bit smaller. So 99 times p hat 2 times 1 minus p hat 2. Put this in the calculator as well. So 99 times 0.313, 3, times 1 minus 0.313. And we get about 21, which is fine. As long as it's greater than 10, we're good. Let's go back and see what the other requirements there were. Sample sizes are no more than 5% of population sizes. Okay, so in this particular example, the population would be babies. And obviously there's a huge population. There's millions of babies. So we're fine for that one. We definitely have less than 5% of babies in this drug study. So let me just make a note. Samples are less than 5% of the population. Usually that one you don't have to worry about unless the population happens to be very small. But usually that's not the case. Okay, so we have the requirements met. So let's go ahead and go to part B, state the null and alternative hypotheses. So for this one, I'm looking for some keywords. I noticed when we were reading the problem, I saw the word lower. Does the evidence suggest that a lower proportion of subjects in Group 1 experienced drowsiness? So this is giving me the key to my alternative hypothesis. The null hypothesis will always have the same structure. It will be that the population proportions are equal. And my H1 I'm getting from that word lower. Did the subjects in group 1 have a lower proportion of infants that experienced drowsiness? So that is my alternative hypothesis. Now I want to go ahead and find the p-value. So I'm going to do that by going to Stat. I'll go across the top to the Tests menu, and this time I want number 6, 2-prop z-test. It stands for 2-proportion z-test. The z refers to the fact that they're using the standard normal distribution to compute the p-value. Okay, so we wrote these down up here, so I'm going to scroll down so we can see them. Okay, x1 was 137, n1 was 452, x2 was 31, n2 was 99. And our alternative hypothesis was a less than, that P1 is less than P2. So we can go down to calculate and press enter. All right, it's giving us a few things. It's giving us a z-score. This is called the test statistic. It just tells us where in the standard normal distribution our sample value lies. And then the second thing right here, this is the most important thing. This is our p-value. This is our probability. So let's go ahead and write that down in the notes. So P is approximately equal to 0.422. It says, do you reject H0? Well, remember that our level of significance alpha was 0.05. So in this case, P is greater than alpha. This means that our sample results are not considered statistically significant. So that means that we do not reject H0. Okay, so what's our conclusion? Well, we do not have sufficient evidence to conclude. We do not have sufficient evidence to conclude that a lower proportion of babies will experience, or say infants, the problem says infants will experience drowsiness if they take Prevnar. Okay, so let's go ahead and try a couple more examples. These ones aren't broken down step by step, but we pretty much follow the same structure. I won't go over the requirements, but we will write the hypotheses, find the p-value, and state a conclusion. An economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. I want to stop right there because we're having some very important information brought up right away. Percentage is another word for proportion, and then we have the word greater. That's giving me a big hint as to what my alternative hypothesis is going to be. All right, let's continue. He obtains a random sample of 800 urban households and finds that 338 of them have internet access. He obtains a random sample of 750 rural households and finds that 292 of them have internet access. Test the economist's claim at the alpha equals 0.05 level of significance. Okay, so let's start off by writing out our hypotheses. The null hypothesis will always be the same. It will be that the proportions are equal. And then the alternative was kind of given to us in this first sentence. He believes that urban households have a higher proportion of people with internet access. So we'll say P1 is greater than P2. Okay, so in order to test this, we need to go to our 2-prop z-tests and get the p-value. So I'm going to go to Stat, arrow across the tests, and we're going to go down to number 6, 2-prop z-test. Okay, so X1, N1, these are the urban household numbers. So 338 people had internet access out of a sample of 800. For the rural households, 292 of them had internet access out of 750 households. Our alternative hypothesis was greater than, so I'm going to go ahead and change that to a greater than hypothesis. And then go down to calculate so we can get our p-value. Okay, my p-value is right here. It's about 0.092 if I round it to 3 places. So the p-value is approximately 0.092. Our level of significance that was predetermined was 0.05. So this time, once again, p is greater than alpha. So we do not reject H naught. We don't have strong enough evidence to reject the null hypothesis. So similar to the above problem, there is not sufficient evidence to conclude that a lower proportion of, what was it? Oh, higher, sorry. Let me change that. That a higher proportion of urban households have internet access than rural households. Okay, so let's go ahead and try one more example. Hopefully you're seeing kind of the pattern of what we're doing, looking for those keywords. The Pew Research Group conducted a poll in which they asked, are you in favor of or opposed to executing persons as a general policy when the crime was committed while under the age of 18? Okay, I'm assuming the crime they're talking about is murder, but we don't have more information than that. Of the 580 Catholics surveyed, 180 indicated they favored capital punishment. Of the 600 seculars, those who do not associate with a religion, surveyed, 238 favored capital punishment. Is there a significant difference in the proportion of individuals in these groups in favor of capital punishment for persons under the age of 18? Use the alpha equals 0.01 level of significance. Okay, so the keyword I'm noticing in this sentence here is difference. The problem isn't giving an opinion as to whether more or a higher proportion of Catholics or seculars would be in favor of capital punishment, just that there might be a difference. And that always refers to a two-tailed test. So our null hypothesis, of course, will be the same, but our alternative will be a two-tailed test, just that the proportions might be different in some way, not really giving an opinion as to which one would be higher. Okay, so let's go ahead and go back into our calculator, and we run our stat tests number 6 to prop z test. Okay, so first we have these values for the Catholics. So 180 favored capital punishment out of the 580 surveyed. For the seculars, 238 favored capital punishment out of the 600 that were surveyed. And then we're using a not equal to hypothesis. And then we calculate, and this should give us our p-value. Okay, so our p-value is the second thing right here. So it's about 0.002 if I round it to 3 decimal places. Okay, so our alpha level was 0.01, so certainly p is less than alpha. Okay, this means that our evidence is strong. It is considered statistically significant evidence. It's the probability of getting these results, if H naught was true, is very low. So this gives us a reason to reject H naught. Okay, so we can say there is sufficient evidence to conclude that different proportions of Catholics and seculars favor capital punishment for minors. Your conclusion doesn't have to be exactly the same as mine, as long as it in some way restates the alternative hypothesis, it should be fine. So if you reject H0, we always say there is sufficient evidence. If you don't reject H0, you say there is not sufficient evidence. And then you write something that sort of captures the spirit of the alternative hypothesis.